So let's take some x values for 5 tosses of a coin. I define x and the corresponding probability, Microsoft Excel, probability such that x is equal to x. And for 5 tosses of a coin, so the possible outcomes are 0, 1, 2, 3 up to 5. Or one more, 5. And the corresponding probabilities for tossing up a coin, the probability in one trial is 0.5. We know for the fair coin. So I define here binomial distribution and number of trials. X. The number S. Number S. Trials are 5 here, and probability in one trial is 0.5. And I would like to calculate individual probability. Therefore, the final parameter probability mass function should be computed. So final variable, which is the Boolean variable, is set to false. Right. And repeat this one for all the cells. So it will pick up the corresponding value. Since this value was computed from the cell in X, the next value is computed from the corresponding cell. So you can see the as you move away from the mean value in normal in binomial distribution, if I say mean, so it is equal to n times the NP. So 2.5, you have the greatest probability for 2 and 3, and you have lower probabilities as you move towards the edges on both sides. There is a probability characteristics. This is a good opportunity to show you. So if I compute the sum of all probabilities, for all the events, so that will be 1. Okay, this is binomial distribution, right? Now I do some test. For example, like I said, if I compute binomial distribution probability for saying 10 heads, 10 trials, the probability of head 0.5, I say false. So let's see this number. So it is 0.001, right? So something that you can say it is significant. But if I compute, no, there must be things that you should do at your own. Saying 40 heads in 50 trials. 40 heads in 50 trials. So it is a number 10 raised to the power minus 6, right? 40 heads in 10 trials. In percentage, 40 heads in 50 trials. So this number is 10 raised to the power minus 6. So do you think it's a significant thing or not? But if you like, you can look for the numbers. Like I said, my claim, normal distribution, 100 out of 100, the probability 0.5, and with saying individual probability. See this number. This number is a real number, 10 raised to the power minus 3, minus 31. Like we performed the experiment in the class for tossing 5 times toss. If we do 100 times and count the heads, so even if all the people on the earth, they perform this experiment, not a single one is going to get 100 out of 100. The same goes with 0 head in the 100 trials. So we have to define the practical limits of the observation, because the numbers will appear according to the computation. So for example, I say now I use the mathematical limit to binomial distribution. Okay. N is equal to 100 and we have P equal to 0.5. Now I define where is the mean value. Mu is equal to NP. Yes, it's right. N times P 50. So around 50 will be the possible events. So let's see how much probability they constitute. Let me show one end. Its values. Here, now in normal distribution, the probability will come from the phi interpretation, right? So probability. Take some values. For example, what is the probability that we get more than 80 heads in 100 tries? More than 80 heads. How much is the probability? So if I define here 80, so I can define before probability, I define the z value. So z value here will be equal to x minus the mean value, define k p, and the sigma value. Okay, sigma value is not here. We have to compute it. Yeah, this is the wrong calculation. So I standard deviation, I compute here SQRT of n times e times q, which is equal to 2.5. So standard deviation is 5. Is it correct? Okay, k1 times k2, k2. Okay, that's fine. So I have taken 80 for x and divide it by 5 value, which is k $4. So z is equal to 6. Square. Okay. So phi value beyond this one, beyond this, the how much is the probability that getting more than 80 heads in 100 tries? It means the probability of 80 heads, 81 heads, 82 heads. Let's compute that. So I compute it. You know the method with the table. I use here the normal distribution, normal dot distribution 1 minus, I say x. Okay, not x. I use the standard distribution, and z value is 6 and cumulative. Here this time I use the 2. So beyond 80 heads, the probability is 10 raised to the power minus 10. In percentage, it is 10 raised to the power minus 8. So these type of events should be rejected on the basis of statistics. Otherwise, you have your own methodology to convince people because your opinions will not be conclusive.